Hello and welcome to Soft Papers channel. My name is Godfrey. In this video, I'll be solving a Cambridge IGCSE chemist topical question on chemical reaction. This is a 2019 October-November exam series. Topical questions are the best way to do your revision as you prepare for your forthcoming exams. I suppose most of you watching this video could be preparing for 2021 June October exams. Therefore, I encourage you to read a given topic, read your notes, read your textbook, and when the contents are fresh in your mind, come and attempt the topical questions you find in this papers I'm solving. That way you will be prepared nicely to tackle your exam successfully and get your A star in chemistry. After all, chemistry is an easy subject when you go topic-wise. Before we start, I will ask you, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you'll be notified every time I upload a new video. Let's get started. Question number 1. And in every question, as I always indicate in my videos, every question you'll find that be given this kind of writing. This tells you which variant. Of course, 062, this is the code for chemistry IGCSE papers. Variant 1, there's variant 1, multiple choices, variant 1 and 2, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. October, November, right? This is 2019, and this is question number 12. So this question was set in variant 1, and it was number 12 in that variant. If you need to refer and also cross-check the marking scheme if you so desire. So let's get started. Equation number 1, equations for the formation of anhydrous cobalt 2 chloride and anhydrous copper 2 sulfate as shown. Anhydrous means without water of crystallization. Hydrated means with water of crystallization. This is hydrated. Likewise, this is also hydrated because you can see it has got water of crystallization right there. This is anhydrous and this is anhydrous. It does not have water of crystallization, as you can see. Which statement about the reactions is not? Which is not correct? The one which is wrong. Of course, both reactions are not exothermic, as it is indicated there. So this is definitely the answer. But let's see what are the other choices say. Both reactions are reversible. Yes, this is correct because you can convert hydrated copper 2 sulfate to anhydrous copper 2 sulfate and turn it back, copper 2 sulfate plus 5 molecules of water. You can convert this one to this one by heating. You can heat for the forward process, and you can turn copper sulfate to hydrated copper 2 sulfate by adding water. If you add water to this, then you'll get hydrated copper 2 sulfate. So both reactions are reversible. This is correct. Same as hydrated cobalt 2 chloride. Part C, hydrated cobalt 2 chloride changes color from pink to blue. That is correct. This is pink, and this is blue. Of course, we usually use this as a test for presence of water. We use this compound, anhydrous copper 2 chloride. You add a few drops of water to the blue anhydrous cobalt 2 chloride, it will turn to pink. That is one of the tests we use to test the presence of water. The other one is also this one. You add a few drops of water to anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate is white. This one is white, and this one here is blue. So both of these compounds, The anhydrous ones are used to test the presence of water. So this is correct. Hydrated copper 2 sulfate changes color from blue to white. That's also correct. So the correct answer here is, the wrong answer here is A, which happens to be our correct answer because we are looking for the statement which is not correct. Numbers 2. Number 2. A method used to investigate the rate of reactions of calcium carbonate with dilute hydrochloric acid under these different conditions, is shown. These are the methods. Place 50 centimeters cubed of dilute hydrochloric acid in a conical flask. Add a known volume of water to the conical flask. Of course, that's to dilute, I suppose. Heat the conical flask to the required temperature. Add 1 gram of calcium carbonate to the conical flask. Measure the temperature. Measure the time taken for the reaction to finish. Which volume of water and which temperature gives the shortest time taken for the reaction to finish, right? So if you add a lot of water, you will make dilute acid. You'll make hydrochloric acid too dilute, and that means that the hydrochloric molecules that are supposed to react with the calcium carbonate will be less. The particles will be less, so the collisions for successful reactions between calcium carbonate and hydrochloric acid will be very minimal. So the water that you should add is little. This is too much, so we don't want to dilute the acids too much, right? So I can give you this: the smallest amount of water, added is or causes less dilution of the acid. So the more acid particles are present for the reaction, more particles of acid per unit volume. So this will mean the reaction is going to be a little bit faster, and therefore it will take the shortest time for the reaction to finish if you have more acid particles per unit volume. So that's why we are saying you need to add little water. Then the temperature, the higher temperature, the more particles with more or equal activation energy. So the faster the reaction will be. So you need a higher temperature. So between 30 and 50, the higher temperature is 50. That's why the answer is B. Little water and high temperature will make the reaction very fast, and it will take a shorter time for the reaction to go to finish. So answer right there is B. Number 3. Which is a chemical change? Which is a chemical change? Boiling water. When you boil water, water changes from liquid to gaseous, and you can return back to liquid by cooling the gaseous or the steam. So this is a physical change because you can revert it back. This is a physical change. What about cooking an egg? Once you cook an egg, of course, you cannot get it back to uncooked, and therefore this is a permanent change, and it's a chemical change. This is a chemical change. That should be the answer because you're looking for what is a chemical change. So B is a chemical change. Let's see why The others are not chemical. When you dissolve sugar in water, you can still get back your sugar, right, by distillation. So this is a physical change. What about melting ice cube? When you melt ice in solid state, when you melt ice, you get liquid water. But you can freeze water back to get your ice. Therefore, these are physical change as well. So the answer right there is B. Number 4. It's great you are watching these videos. As I always encourage my students, you need to practice working out these questions yourself as I guide you through. And you may get this same paper I'm solving right now from Solve Papers from this site here, which is over here. I may show you this. This is a Solved Papers here. This is the site I'm talking about. It's a very resourceful site with a lot of CIE materials. So I need you to come here. Chemist, go to 2019. You have solving 2019 topicals. You get to 2019 topicals, and you'll be brought to this page. You can get 2019 November topicals, both multiple and structured. Of course, there are some solved topicals right there. You can also get for June multiples and structured as well. So some of them are downloadable. You can download the ones that are available. The ones that are not available, you need to click here. Click here to get all solved topicals in zip folder. So you'll come here and you'll find there's some products here that you can get for yourself. Don't hesitate to spend a little to be able to boost your chances of getting an A-star in chemist. So just £8 for both chemist and physics. You'll be able to get this for both structured and multiple choice. Ask your parents to help you with this, and when you get the papers, come back to the video and let's help you in solving these questions. So let's continue with number 4. Number 4. Mercury Two Oxide, because this one decomposes when heated. The equation is shown. When you heat mercury oxide, Mercury 2 oxide, you get decomposed to give you mercury and oxygen. Why is this reaction? Why is this a reduction reaction? Of course, you can see when you heat mercury here, you get Mercury 2 oxide here, you get mercury. So you can say that mercury has lost oxygen. So loss of oxygen is reduction, okay? And addition of oxygen is oxidation. So because mercury has lost oxygen, then the reaction is a reduction reaction. So look at the multiple choice. The products weigh less than the reactants. That is not why the reaction is a reduction. There are fewer reactants than products. That is correct. We only have one reactant, reactant and 2 products. That is correct, but that is not why this reaction is a reduction reaction. There is a gain of oxygen. You can see there is a loss of oxygen. So both of these are not correct. So there is a loss of oxygen. That should be the correct answer. B. Number 5. Which reaction produces a white colored substance? Which reaction? Adding water to anhydrous cobalt 2 chloride. Anhydrous cobalt 2 chloride is blue. When you add water to it, you get a pink hydrated cobalt 2 chloride. So that does not produce a color substance. When you add water to this is blue. It will change to pink. So that is not white color substance. So that's not correct. Adding water to anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate is actually white. When you add water, it turns blue. And therefore that is not correct. Now part C, heating hydrated cobalt 2 chloride. When you heat cobalt 2 chloride is pink. When you heat it, it turns to anhydrous cobalt 2 chloride, which is blue. Alright, so that's not correct. We want which product or which is white. Heaty hydrated copper 2 sulfate. Hydrated copper 2 sulfate is blue. So when you heat it, you get an anhydrous copper 2 sulfate, which is white. Therefore, the right answer here is D. Of course, I can give you the equation here. Copper 2 sulfate, hydrated copper 2 sulfate is that one. So when you heat it, you get copper sulfate plus water. Now this compound here is blue and this compound here is white powder. So you have gotten your white colored substance right there by heating hydrated copper 2 sulfate. You get copper 2 sulfate anhydrous. Number 6. Number 6, 4 students collect the gas produced from the reaction of calcium carbonate with dilute hydrochloric acid. Each student records the time taken to collect a volume of gas. Of course, when calcium carbonate reacts with HCl, what you get is the salt, calcium chloride, carbon dioxide, which is the gas they are collecting, and water. Okay, this is solid, and this is aqueous. This is aqueous as well. Of course, there's 2 there. So, which results show the highest average rate of reaction? Right. So here, you need to find the ratios. Find ratios. And you're told 15 centimeters cubed of gas collected in 20 seconds. So 15 in 20 seconds. 50 collected in 40 seconds. 50 centimeters cubed collected in 40 seconds. 75 centimeters cubed of gas collected in 80 seconds, and 90 centimeters cubed of gas collected in 100 seconds. So then find the ratios. Of course, this is going to be divided by 5. You get 3. Let me change color here. You find this is 3 to 5. Sorry, to 4. 3 to 4. Okay, this will give you, when you divide by 10, this will give you 5 into 4. When you divide this one by let's say by 2, you will get 37. Let's say by how much here? What do we divide to get 4? You get 4 here. This one you get 3.75. When you divide by, that is 10, that is you divide by 20. Then here you divide, you get by 25. You get 4 into 3.6. So you look for the one which has got the least ratio, and that happens to be you look for the one which has got, because the question is which results show the highest average rate of reaction, right? Average rate of reactions giving you more volume of oxygen per given time, and you find that the time is 4. The smallest ratio for the time is 4 for all of them. So the one that is giving us the most is this, which happens to be the 50 centimeters cubed in 40 seconds. That's why the answer here is B. Okay. Number 7. Which row identifies chemical and physical change? A chemical change. Boiling ethanol is not a chemical change. Burn ethanol is a chemical change. Dissolve ethanol in water, this is not a chemical change. And evaporate ethanol is not a chemical change. So apparently it looks the answer is going to be B, but let's change. Let's see a physical change. Burn ethanol is a chemical change, it's not a physical change. Evaporate ethanol, this is a physical change. Burn ethanol, chemical change. Dissolve ethanol in water, this is a physical change. So both chemical and physical change. Which row? The row is B. So B gives us both chemical and a physical change. Number 8. When magnesium is heated with zinc oxide, a reaction occurs. The reaction is shown. Magnesium, which substance is oxidized? Oxidation is the addition of oxygen. You know that. Oxidation is addition of oxygen or removal of hydrogen. And so magnesium, you can see magnesium here has gained an oxygen here to get magnesium oxide. So magnesium is oxidized. Magnesium is the one which is oxidized. As zinc oxide is reduced. It has lost an oxygen and therefore it is reduced. So magnesium oxide is obtained by oxidizing magnesium. Therefore magnesium is oxidized right there. Question number 9. Question number 9. Before we tackle question number 9, I need to let you know that I do online tuition for chemistry and physics, and I need you to have a look at this side, spacademy.co.uk. This is the site that I used to do my tuition. This is the site I'm talking about. Okay, we do these subjects: chemistry, mathematics, physics, biology, and ICT. So I need you to come here if you're a student to have a look at this guide, a step-by-step guide on how to sign in. Also, you can find time and watch this video. This will help you get to know our online live classes functionalities. So I need you to log in and sign, register. Log in and register. Of course, you need to give the correct email. We will send you an email. You need to click the email and activate. Then you'll be able to sign in. And therefore, once you sign in, you're able to get to your dashboard, and you can now book a tuition with one of the tutors of your choice. I hope to see you in my tuition class. Let's continue with numbers 9. Number 9. Hydrated cobalt 2 chloride. Hydrated cobalt 2 chloride, no, it is pink. Decomposes when heated to give us an hydrous cobalt 2 chloride, which is blue. This one here. Which statement about these reactions are correct? This cobalt chloride is an hydrous cobalt chloride. That is correct. Heat is released when water is added to anhydrous cobalt 2 chloride to get hydrated cobalt 2 chloride. That is correct. You get heat. This is blue. No, this is pink. That is pink. The reaction is not reversible. Actually, the reaction is reversible. You can heat. You heat hydrated cobalt 2 chloride to get anhydrous cobalt 2 chloride, but then when you add water to anhydrous copper 2 chloride, you get back your hydrated copper 2 chloride. So this is a reversible reaction. So this one is not correct, and also this one is not correct. So the correct answer is 1 and 2, which happens to be A. Number 10. In an experiment, in experiment 1, small lumps of limestone are added to dilute hydrochloric acid at 40 degrees in experiment 1, this one here. The volume of carbon dioxide released is measured at regular time interval, volume of carbon dioxide. The results are shown. Which changes gives the results shown in experiment 2? Okay, experiment 2 basically means the reaction is not fast. Okay, the reaction is slow in experiment 2, and therefore for you to slow down the reaction, of course, experiment 2 is slow. You can notice that this is the experiment 2 here. You can see the dashed line. This is experiment 2. So experiment 2 is slow. Okay, you can see it is producing less volume of oxygen. Like for example, if you take a given time here, let me draw from up. If you get a given time here, okay, the volume of oxygen, volume of carbon dioxide that is produced is same as for a shorter time here for experiment 1. You see, in experiment 1, it took less time to produce the same volume of oxygen, which took experiment 2 a longer time to get. So experiment 2 is slow, and for the reaction to be slow, then the temperature should be low. The temperature should be low, or use calcium carbonate of small surface area. The calcium carbonate should have small surface area. Basically, use lumps instead of powder. Use lumps of calcium carbonate. Lumps of calcium carbonate have got a small surface area compared to powder. So the limestone should be in lumps, right? If it is in powder, then the reaction will be faster. Even so, it should be large lumps, and the temperature should be less. Of course, between 60 and 40, this is less. So that's why the answer is A right there. Number 11. A sequence of changes involving sulfur is shown. Sulfur in change 1 changes to sulfur liquid. This is solid. It changes to liquid, and here it changes to sulfur dioxide right there. So which row, A, B, C, D, describes the change? So in change 1, sulfur has just melted, and therefore that is a physical change. It is not a chemical change, right? Then in change 2, sulfur has reacted with oxygen to give us sulfur dioxide. So that is a chemical change. That is a chemical change. So the correct answer here is C. The correct answer there is C. You can also say in change 2, an oxidation has occurred. We have oxidized, sulfur has been oxidized to sulfur dioxide, and oxidation is usually a chemical change. Oxidation is a chemical change. Number 12. Numbers 12. Which equation is ion oxidized? Right? Oxidation is the gain of oxygen. We know that. This is gain of oxygen. That is oxidation. Therefore, let's look at the first equation here for part A. So this is carbon and this is iron oxide. What has happened here is that carbon has picked the oxygen from from iron, and therefore iron has been reduced. This is the reduction, right? What about here? We are looking for the one where iron is oxidized. So in this one, iron has lost oxygen, and when it reacts with carbon monoxide, and we get iron here. So likewise, iron has been reduced here, okay, because it has lost oxygen. What about this one? Iron here has lost some 2 oxygen to get to iron oxide, right? This is iron 3 oxide. It has been converted to iron 2 oxide. Therefore, this also iron has been reduced. It has lost some because it is being converted from this to this. So it has lost some 2 oxygen right there. So loss of oxygen is reduction, and therefore the right answer should be D, because hydrogen iron here has gained an oxygen to be converted to iron oxide, and this is oxidation. So the correct answer is D. Number 13, which is a chemical change? Of course, this one without hesitation, we've looked at it. You just go for B. Let's go for B. Cookie and egg is a permanent change. Therefore, that is chemical change. Number 14, the rate of reaction between magnesium dilute hydrochloric acid is increased by increasing the concentration of the acid. That is correct. By increasing the concentration of the acid, you increase the number of hydrochloric molecules, and therefore the reaction tends to have more collisions, and the reaction goes faster. The rate will increase. How does this affect the reactive particles? So the collision rate of particles will increase. That is correct. It will not stay the same because you have increased the concentration of more hydrochloric molecules. And what about the proportion of particles with sufficient energy to react? By increasing concentration does not affect the energy the particles have, so this is not correct. The energy stays the same is right, and of course this is not correct, this is correct. Therefore the correct answer should be B. Activation energy is affected only by the change in temperature. So if we had a change in temperature there, it will affect the activation energy, the energy, sufficient energy to react. So since there is no change in temperature, that remains the same. Number 15. Dinitrogen tetroxide, this compound here, is converted to nitrogen dioxide, this compound, in a reversible reaction. The forward reaction is endothermic, consumes heat from the atmosphere. The forward reaction is endothermic. Which conditions give the highest yield, gives the highest equilibrium yield of nitrogen dioxide? Right? So when you look at the reaction, we have 1 mole on the reactant side, while we have 2 moles in the product side. So basically means there for a highest yield of the product, the pressure should be low, because you're getting more molecules in more moles in the product side as compared to the reactant side. Therefore, the forward side will be favored by low pressure. So the the pressure should be at least 2. 50 is too high. Will favor the backward reaction. Then, since the reaction is endothermic, the temperature should be high. High temperature favors the forward reaction. Remember, the forward reaction is endothermic, and therefore, when you increase the temperature, the forward reaction will, the equilibrium position will react in such a way to lower the temperature, and therefore you'll get more of the products right here. So high pressure will cause position of equilibrium to shift left. High pressure, at high pressure, equilibrium shifts left. Equilibrium will shift left. And that is not what we want. We want the equilibrium to shift to the right. And high temperature, equilibrium shifts to the right. Equilibrium shifts right. And that's what we want. So high temperature favors forward reaction, since the reaction is endothermic, and therefore we want high temperature. Reaction is, remember Litocharia's principle, right? This is based on that. This question. Let's go to question 16. Question number 16. The equation for the reaction between iron sulfate and bromine is shown. Iron sulfate plus bromine gives us iron 3 sulfate. This is iron 2 sulfate. This is iron 3 sulfate. And then we have bromine, iron bromide. Which row identifies the oxidizing agent and the reducing agent? Okay. Now, oxidizing agent gains electrons, and reducing agent gives out electrons. So you can have that in mind as you answer this question. Oxidizing agent, this one gains electrons. And reducing agent, this one loses electrons. Okay, or gives electrons. Let me use that. Gives electron. Losing electron is also the same. So let's look at these two compounds here of iron. We have iron sulfate, and then we have iron sulfate here. This is iron 3 sulfate. All right. So the oxidation state of iron here, the oxidation state of this iron here is +2, because sulfate ion has got an oxidation state of -2, and therefore one ion is needed for one sulfate ion. So the oxidation state is +2, and the oxidation state here, because it has got 3 here, is +3. Okay, so what has happened? Iron 2 sulfate has lost an electron to be converted to iron 3, Okay, so oxidation states of iron has changed from +2 to +3. So it has given out an electron. So it is a reducing agent. Don't forget, we are looking at identify an oxidizing agent and a reducing agent. So since this one has given an ion, it's given out an electron to be converted from +2 to +3, then iron 2 sulfate is a reducing agent. So this is a reducing agent right there. Now what has happened to bromine? Bromine has been changed from, we have bromine, this one here, be changed to bromide. Bromide is with a negative charge. So bromine has gained an electron. This one has gained an electron to be changed to a bromide. Bromine has gained an electron to be changed to a bromide. So bromine is the oxidizing agent. So the oxidizing agent here is bromine. Therefore, the answer to this question is A. The oxidizing agent gains electrons, reducing agent gives out electrons. So the answer there is A. Number 17. Number 17. A sample of dilute nitric acid is added to lumps of limestone in a conical flask. All right, lumps of limestone. Limestone is calcium carbonate. The conical, of course, in solid form. The conical flask is placed on a balance, and the loss in mass is measured. Of course, we know that when nitric acid reacts with calcium carbonate, we get calcium nitrate plus carbon dioxide plus water. So this gas will be lost. That's why the mass will decrease. Okay, so a second sample of nitric acid of a different concentration is separately tested. All other conditions are kept the same. Now the only difference is concentration of different concentration, either more concentrated or less concentrated, we are not told. The loss in mass in 1 minute of each concentration of nitric acid is shown. So when concentrated sulfuric acid is having, when the concentration of nitric acid is less, the loss is mass in 1 minute is 0.15 grams. Of course, when the concentration is 1 mole per liter, the loss in mass is 0.25. So it means that the higher the concentration, the faster the reaction, so that we have more carbon dioxide produced, and that means that more is lost. Which row describes, which row, A or B, C or D, describes and explains the results obtained using concentration of 1 mole per liter nitric acid compared to this, right? So description, decrease in rate. Of course, you can see the more mass is lost. So that means when we have more concentration of 1 mole per liter, so it means that reaction is fast. So the rate of reaction is not decreasing. The rate of reaction has actually increased. And then explanation is that, of course, we only concentrate with C and D. A and B are out. Increase in particle collision. That is correct, because you have more particles in a concentrated acid than a less concentrated acid. So that is correct. What about C? Increase in particle collision rate and collision energy. We have not changed the temperature, so there's no change in collision energy. So the right answer here is C. C is the right answer for that question. Number 18. When carbon monoxide reacts with hydrogen, methanol is produced. So we have this equation here. Carbon monoxide reacting with oxygen to give us methanol. Methanol is an alcohol. The forward reaction is exothermic. Which statements are correct? Okay. Of course, let's look at the statements to decide which one is correct. There are more moles of gas on the left-hand side of the reaction. More moles on the left-hand side. Both of these are gases. Carbon monoxide is a gas. Hydrogen is a gas, methanol is a gas. So how many moles do we have for carbon monoxide? 1. We have 2 moles of oxygen, and we have only 1 mole of methanol. So on the left hand side, we have 3 moles. 1 plus 2, this is 3 on the left hand side, compared to 1 mole on the right hand side. So there are more moles of the gas on the left hand side of the reaction. That is correct. Increasing the temperature increases the amount of methanol at equilibrium. This is not right, because we are told exothermic reaction, forward reaction is exothermic. So according to literature, when you increase the temperature, the reaction, the equilibrium position reacts in such a way to decrease the increase in temperature, and therefore more of the reactants will be produced. So at high temperature, less methanol will be produced. So this is not correct. Increasing the pressure increases the amount of methanol at equilibrium. This is correct. Increasing pressure, the equilibrium position will shift in the direction of the fewer molecules, and therefore, since on the left hand side we have 3 compared to 1 on the right hand side, the product side, then at high pressure more methanol will be produced. That's why this is correct. Number 4, increasing the initial amount of hydrogen decreases the amount of methanol at equilibrium. Of course, according to literature, even increased a reactant, more of the product will be produced. That is, the equilibrium position will will shift in a way to reduce the increased reactant, and therefore means more product will be produced. So meaning, say, decreases of amount of methanol is not correct. Therefore, it's 1 and 3 which are correct, and that means B is the correct answer for this question. That's right. Number 19. In the blast furnace, iron is formed when iron 3 oxide reacts with carbon monoxide in a redox reaction. The reaction is here. Iron 3 is reduced by carbon monoxide to iron, and carbon monoxide is oxidized to carbon dioxide. So you can see there. Which substance is oxidizing agent? Which substance is an oxidizing agent, and which substance is a reducing agent? So of course, we have said in a previous question up there, oxidizing agent will gain electron, or it will give out oxygen, and reducing agent will gain the oxygen that is given out. So in this case, you can notice that iron 3 oxide has given out its oxygen and has been converted to iron, right? So that means that iron 3 oxide is the oxidizing agent. This is the oxidizing agent. Okay, and carbon monoxide has gained an oxygen and has been converted to carbon dioxide. That means carbon monoxide, because a reducing agent will gain an oxygen, carbon monoxide is the reducing agent. So look at reducing agent, we have said is iron 3 oxide, and oxidizing agent, and reducing agent is carbon monoxide. So the answer is B. Okay, let's proceed to question number 20. Question number 20, magnesium reacts with dilute hydrochloric acid. Which statement about the particles in the reaction is correct? Increasing concentration of dilute hydrochloric acid increases collision rate, but has no effect on the activation energy. This is straightforward correct. The rest are not correct. Let's see why they are not correct. Increasing the concentration of dilute hydrochloric acid increases the collision rate and the activation energy. It does not increase activation energy. Activation energy is not altered. We only increase the energy of the colliding particles when we increase the temperature. Part C, increasing the temperature of the reaction increases the activation energy. We don't alter the activation energy of a reaction by increasing temperature. We only energize the particles such that they have energy equal or above the activation energy. So increase in temperature does not increase the activation energy. That's why this is not right. Also, this one is not right. Then D, increasing the temperature of the reaction causes all collision to lead to a reaction. That is not right, because some of the particles, even if you have increased the temperature, may collide in the wrong radiation, and that will not lead to a successful collision. So the correct answer here is A. Question number 21. Two molecules of nitrogen dioxide combine in a reversible reaction to form dinitrogen tetroxide. The forward reaction is exothermic. Of course, the reaction is given right here. Which changes in reaction conditions would both increase the amount of dinitrogen tetroxide at equilibrium? The reaction is exothermic, and we have 2 moles on the left hand side while we have 1 mole on the right hand side. So increasing pressure will shift the equilibrium position to the right. Decreasing temperature will also shift the equilibrium position to the right and produce more of dinitrogen tetroxide. So high pressure and high temperature will be key here. So here we are decreasing, high pressure and low temperature. So in decreasing the temperature and decreasing the pressure, decreasing temperature is correct, but decreasing pressure will shift the equilibrium position to the left, so it will not produce more of nitrogen tetroxide. So this one is not correct. Decreasing temperature and increasing pressure, we have said that is their ideal. Decreasing temperature because the forward reaction is exothermic. According to literature, when we decrease pressure, the equilibrium shifts to increase pressure. When we decrease temperature, the equilibrium position shifts in such a way to increase the temperature, and that means that more of the products will be formed. So I'll go for B as the right answer. Why is C not right? Increasing temperature will shift the equilibrium position to the left because the forward reaction is exothermic. So you don't increase temperature. And also, of course, D, increasing temperature. Don't worry about pressure. As long as one is wrong, then the rest cannot be, the rest of the equation cannot be, the rest of the statement cannot be right. So the reaction, the equation, that right answer there is B. Question number 22. Chlorine displaces bromine from aqueous potassium bromine. The ionic equation of the reaction is given here. Of course, potassium is a spectator ion, therefore we only write the ionic equation without it. Which statement about this reaction is correct? Bromine gives its electrons to chlorine. You can see bromine has been converted to bromine atom. Therefore, it has given its electron to chlorine. Chlorine was an atom, now it is an ion, and therefore that is correct. So you can say bromine gives its electrons to chlorine. That is correct. So since bromine has given its electron to chlorine, bromine is an oxidizing agent. Bromine is, it has been oxidized, Bromine has been oxidized, and chlorine is reduced. Don't forget, oxidation is loss of an electron, reduction is gain of electron. Okay, and therefore the one which is reduced is the oxidizing agent, and therefore chlorine is the oxidizing agent. And consequently bromine is the reducing agent. So let's look at the choices. Bromine ion acts as an oxidizing agent. That is not correct, because we have said oxidizing agent is chlorine. Bromine ions are oxidized. We have said already that bromine ions are oxidized when electrons are lost. Therefore, this is correct. So which statement is correct? So I'll go for B. B is correct. Chlorine acts as a reducing agent. That's not right. Chlorine is on the oxidizing agent. Chlorine is reduced when electrons are lost. Chlorine has been reduced by gaining electron, not when electrons are lost. That's why that is not correct. That's it, guide for these chemical reactions. October-November 2019 topical question. I hope to have helped you, and I'm looking forward to see you in my next video. Cheers.